have a little think about two concepts which are sometimes muddled up, namely weight and mass. Now this is an example where physics gets confusing because we use words in a slightly different way, in a slightly more precise way than we do in everyday life. So in everyday life, if I put myself on the scales, I might say, oh look, I weigh 80 kilograms. Well, actually that's not true from a physics point of view. What I've just done is I've measured my mass. So mass is a measure, roughly speaking, of the amount of matter, the number of atoms in an object. It's the amount of stuff, and it's measured in kilograms. And the mass of an object, my mass, 80 kilograms, will stay the same if I go to the moon, if I go to Jupiter, if I flew near the sun. It wouldn't itself, those changes wouldn't make any difference to my mass. It's just a property I've got, the amount of matter in my body. Weight, on the other hand, is a force, and it's the force of gravity on an object. The force due to gravity on an object. Weight is the measure of how much gravity attracts an object. On the surface of the Earth, you've got the Earth here, then every object is being pulled towards the surface of the Earth by a certain force. And that force is what we call weight, sometimes symbolised with W. And weight, as we know, is measured in newtons. Unlike mass, weight changes. If you, on the Earth, you weigh a certain amount. If you were to measure your weight on the moon, you'd weigh less. In fact, you'd be about 6 times lighter on the moon. If you took yourself to Jupiter, which has a very strong gravitational field, there'd be much more gravitational force on you, you'd weigh more. So we can convert between the two, and the equation, as you may know, that we use to do that conversion is weight is equal to your mass multiplied by something called the gravitational field strength. Okay, sometimes we just write that as W equals M times G, G for the gravitational field strength. So what is G? Well, if I rearrange that equation, we can work out what it is. G is W divided by M. It's a measure of the force on a single kilogram. So if I take my kilogram on Earth and I put it on some scales, it will weigh 10 newtons. So on the Earth, G is 10 newtons per kilogram. If I took it to the moon, then it will weigh, my single kilogram will weigh about 1.6 newtons. So the gravitational field strength on the moon would be 1.6 newtons per kilogram. So G is a measure of how strong gravity is. It's a measure of the gravitational field strength. And that's therefore the difference between weight and mass. Mass, the amount of matter in your body, doesn't change. The weight that you have does change depending on the G value, depending on the gravitational field strength. So a very easy way to lose weight would simply be to fly to the moon. You wouldn't have to lose any mass, keep the same mass, don't have to go on a diet, but you'd only weigh 1/6 of your weight on the Earth. The reason, of course, is because the moon has a much weaker gravitational field than the Earth.